Okay, so here's where we are, of course. We are in Monday morning geometry, term 4, week 4. So that's a good thing. We moving right along. All right, so we had a discussion earlier about the vaccine. And again, because all citizens now at least 18 years or older are able to get vaccinated, do you think the virus spread will subside? So um I want to know, over the weekend they had a oh, I don't have to record this one. Okay. So we are in math, we're looking at circles. So these are repeats. Again, these were the angles we saw inside the circle and we classified them. These are the arcs. And for this slide, I took out the extra pieces so that you can see the minor arc is the arc between point A and point B. A semicircle is half of the circle. And again, you either go up top from E through A to C, or you can go down the bottom from E through D to C. And there is a major arc. So if the point between A to B going to the right is the minor arc, then the edge from A going to the left, so you name one of the letters that you pass as you go to B. So minor arcs are named in 2 points. Semicircles and major arcs are named in 3 points. And again, every circle that has an angle has a major and a minor arc. Or you can divide a circle, into a major and a minor arc. And remember, the minor arc is 0, greater than 0, but less than 180. A semicircle is 180 degrees even. And a major arc is greater than 180 degrees. Okay? All right. Then on this one, and this is where we left off last Thursday. All right, these were the angles. The angles were the angles that you all picked out in the beginning. So from the angles, we named the major and the minor arc that was associated with them. So for those that were semicircles, again, this was the top of the circle, EAC. This was the bottom of the circle, EDC. And we know a semicircle is 180 degrees. Then here, this can't be right because the 2 should total 180 degrees. So if the distance from F to E is 50 degrees, then the major arc should have been 310 degrees. Because again, the measure of the minor arc plus the measure of the major arc is the entire circle. So then again, we looked at this circle, APC. Again, the measure of the minor arc and the measure of the major arc together, 360. DPD was a semicircle. And again, we looked at D going to the left, from B going to the left to reach D. And then we went from B going to the right to reach D. And again, you just have to name one point in the middle so that the reader will know what direction you are going, which portion of the arc you are talking about. And the last one was DPA. And again, DPA had the minor arc. Hello, good morning. The minor arc goes from D to A, going to the left. And the major arc, we start in that D going to the right to reach A. And again, we know that because B is in the middle. So that means we started at D, we moved past B, and we ended at A. Okay. Oh, we ended at A. So if the minor arc was 140, then the major arc has to be 220 degrees. Okay, makes sense? Okay, so now, excuse me. So now, let's look at this. So there are several angles in the picture. So we are going to fill this slide out as we go. So name an angle that you see.
I see AP.
All right, we went from A to P, and then which way we going, left or right?
Left, right?
It doesn't matter.
We can go left.
All right, so we going A, P, E. So we going from A to P to E. Okay, now, so what type, classify the angle. You went from A to P to E. So first, is it in an inscribed angle or a central angle?
That's an inscribed angle.
Is it? It has its vertex at the center of the circle. So what kind of angle?
Oh no, I'm not for that's a central angle.
Yes. All right, cool. So now we know it's a central angle. And what type of angle is it? Pull back on your old school geometry. What kind of angle is APE? Like, how will we figure out the measure of that angle?
That's an obtuse central angle, ain't it?
Not obtuse. Obtuse is greater than 90.
Oh, wait, hold on.
What kind of angle is that? And this line should be on 0. Let me see if I can move it over.
Oh, that's what's throwing me up. All right, because it was
just move it over. I'm gonna move it over. What kind of angle is it?
Wait, hold on. Well, you're talking about refreshing like major and arc and all that?
From A, no, well, yeah. So what's the measure from, well, first of all, look at this angle. What kind of angle is that? I said pull on your old school.
That's a right angle.
Exactly. So if it's a right angle, how much does it measure?
90 degrees.
Okay. Yes. So now, so we're going to say this is 90 degrees. Exactly. Okay. So we got it's 90 degrees. Excuse me. Because it is a right angle. So now, let's name the minor arc. And let's name the major arc. So we talking A, P, E. So remember, minor arc, less than 100, between greater than 0, but less than 180 degrees. So what's the minor arc associated with angle APE? And what is the major arc associated with angle APE? So let me do this. And I can always put them back. So let me I'm going to take this out because I'm just going to keep the angle we talking about, okay? I'm going to take out all the other stuff. And we're going to move. Let me see if I can move it back. Ooh. Oh, let me move it back a little bit. All right. So this is the angle we're talking about. Angle APE. We said it's a central angle, yes, because it has its vertex at the center, and I'll line those lines up a little better. And we also know that the measure of this angle is 90 degrees because it's a right angle. So now, my question is, name the minor arc and name the major arc. And again, the minor arc has a measure greater than 0, but less than 180 degrees. And the major arc is greater than 180 degrees. So what you got? What you got? Okay. You between.
Wait, hold on. All right, so you said my fault. You said major and minor, right? This is a.
No, I want you to name if this is the angle we talking about, right? Mm-hmm. Then I want you to tell me what two arcs, one is a minor and one is a major, are formed by this angle.
This is minor arc, ain't it?
Which minor? Name the minor arc? It goes from where to where? It
goes from A to F. No. Yeah.
No, where's the end of the arc? No, where's the end of the angle? What is the angle?
No, A E F.
No, remember
hold on. My fault.
Listen, you doing the minor arc, 2 letters. Where does it start? Where does it end? You already said it starts at A. I agree.
Oh, so A-E. My fault. A-E.
Yeah, thank you, boo. All right, so the minor arc goes from A to E. So if the minor arc goes from A to E, we went from A and we went to the left. Then for the major arc, we have to start at A and go to the right. And again, it is a major arc, so you got to name it in 3 because the middle term tells direction. So what's the major arc? We can go back for the measures. What's the major arc?
So with the major arc, wait, I just said the major arc, right? Oh no, that was the minor. Okay. So the major is APE.
APE is the angle.
All right, so AFE.
FE. No, I'm sorry, I moved the slide. You went the same way. You went the same way. We said A to E. Mm-hmm. Right? So if you go from A to E as the minor arc, I agree. You started at A and you went to the left. That's the minor arc. So for the major arc, you got to start at A and go which way?
The right way, right?
Yeah, go to the right. So you pass a whole lot of people on your way to the end. Just pick up one of them. You start at A, pick up any one of these.
Oh, A and B.
All right, so A, B, and where is it going to end?
A, B, P.
P is in the middle. Stay outside. You walking around.
A, B.
Where does the angle end?
Oh, G. This is G right here.
No, where does the angle end? Keep
oh, E. E.
Yes, remember, it is going to make a whole circle. So, the major arc, we start at the same place. So, we starting at A. But we are going to pick up B on our way to E. So, the major and minor arcs start and stop at the same place. The difference is you have the letter in the middle of the major arc tells you your direction. So now let's go back and let's see if we can figure out the measure of the minor arc. So it starts here, 270. So let's count. 5, 10. We can count, since it's on the number, let's count by 10. So we start here, 10, 20, 30, 40, 50, 60, 70, 80, 90. So the measure of the minor arc is also 90 degrees. Good morning. Oh, I don't know what I just did. Go back. Control. Oh, wait. Oh. That just went real haywire. Control copy. Control paste. Okay, so the minor arc is 90 degrees. So the measure from A to E is 90 degrees. So if the minor arc is 90 degrees, what's the measure of the major arc? Remember, the two together form a complete circle. So if the portion of the circle from A to E is 90 degrees, what is the portion of the circle from A going past B and ending at E?
I just said. Oh wait, cause I know. All right, I'm not just do the whole circle. Cause I know the whole circle is 260.
Yep. And you know this portion
is 90.
So what's left?
90.
No. The whole circle is 360.
Oh shoot, hold on.
You said that. You just said the whole circle is 360. I said yes.
All right, hold on, 360. You got 270 left.
Who?
270.
All day. Exactly. Because again, the two measures together total 360 degrees. All right, so ladies and gentlemen, so we see here that this is a central angle, but we see that the measure of the central angle is equal to the measure of the arc. Okay? So, we are going to add that. So now, if you know the measure of the central angle, then you also know the measure of the arc. Let me see if I can squeeze this in here. All right, so here again, we see the measure. Because this is a central angle, the arc has the same measure. Okay, so this is a central angle. It is a right angle, which is 90 degrees, and we found that the measure of the arc is also 90 degrees. Now, it depends on the type of central angle you have, which one, the minor arc or the major arc, will be a central angle. But it may not be a central angle, and we're going to discuss that depending on what you all choose. Okay, but here, the measure of the angle and the measure of the arc are the same if it's a central angle. Oh, excuse me. Gosh, I didn't know it was all that. Sorry about that. All right, so anybody see another angle? We just did angle APE.
Yeah, I see another one.
What you
I
say?
think. Can BPD be one or no?
BPD, yeah, that's a straight angle. All right, so DPB. All right. So now we got angle, ooh, Daisy. DPB as in boy. All right, so I'm going to take out all of the lines that do not relate to the angle that you are talking about. Okay. So, what we got? What type of angle is it? What kind of angle is it?
Class, it's a straight angle.
Oh, okay. All right. Look, I was checking. Everybody got all right. So, yep. So, STRAIGHT. All right. So, it's a straight angle. And what, as it relates to the circle, it is the what? Because it goes from one side of the circle to the other through the center. That makes it a, what kind of, what's the line? All right, so what's the measure of a straight angle?
It's a straight angle.
Mm-hmm. How much does it measure?
Wait, that's 180, right? Because it's going through the circle.
Okay. Yep. Oops. Okay, yep. It's 180 degrees. And again, it is a semicircle. So all right, so it's a semicircle. So let's see. Okay, so therefore, if since it's a semicircle, again, up top, up, you can go up top or down the bottom. Okay. I'm near. All right, let's see. We got one more.
Wait, what was the? I'm trying to do two things at once.
Okay. This is what you said, and I agree. All right, we looked at angle DPB. And again, I took out everything else. So all we can see is that angle. It is a straight angle because it's the diameter. It goes through the center of the circle. Therefore, it measures 180 degrees. So, because it's a semicircle, there is no major or minor arc. Okay?
What you say? I'm sorry, my internet messing up.
I said, because it is a semicircle, you do not have a major or minor arc. You just have two parts of the semicircle. So you either, again, you go up top, and you can go. So let's start where you want to start. You called the angle DPB. That's the angle. So let's talk about what's one semicircle or the other semicircle. Name them.
Semicircle.
Remember, you got to name a semicircle in 3 points.
Yes, so can you do, wait, you said 3 points. Can I do?
Where does it start? Where does it pass by? Where does it pass through? And where does it stop?
Hold on.
All right.
BCE.
BC. Where does it stop? Where does the angle stop? BC who?
BCE.
You went past.
I'm D.
Oh, okay. All right. So that one, you went from B, you went to the right to reach D. So what's the other semicircle? Go to the what?
I gotta go to the left, right?
Exactly. So go to the left.
B.
Yep. Pick up anybody.
BAD.
Yep. Okay. So there are no major and minor arcs. You just have a semicircle. You got one to the left of our angle, and you have one to the right of our angle. All right, last one. We're going to try. Let's see what we have. I think we should have another one. Okay, here we go. Damn. Okay. Name an angle you see.
You want another one?
Last one.
Hold on. I got my screen put up this way. Can you do? I'm trying to see if this is an angle. Hold on. Dad, I'm the only one in class.
You're just a vocal one. That's okay. That happens. That happens.
Can you do? Let me see. No. Two. FD.
Go all the way to the edge. Don't stop
FD.
in the
That's what I was trying to figure the other one.
FD. Where you going?
FDP.
Keep going. That's why I say go all the way.
Oh, so I was correct when I was about to say B.
Yes.
All right.
All right. So we have FDB. All right, so again, I'm going to take out everything that's not related. That's out. That's out. That's out. All right. So now that's what we have. So what type of angle is it? Is it a central angle? Is it an inscribed angle? Is it a straight angle? What kind of angle is it?
It's a what I say? It's an inscribed angle. So it's not straight.
That's right. It's inscribed because its vertex D is on the circle. So this is NSCR. Okay. So now here is where it gets a little tricky. We only know, if we know the measure of the central angle, we know the measure of the arc. But with an inscribed angle, when we find the measure of the arc first, because the inscribed angle is, does anybody remember how does the inscribed angle relate to the arc? Because this is supposed to be a review. Anybody remember?
Oh, I need a refresh on that part.
Okay. So the measure of the inscribed angle is half the measure of the arc. So let us jump to the arcs first. So now we have an arc between where? Where would you think the minor arc would be? And think about your angle, FDB. Where does that angle cut the circle? If we were taking out this slice of pizza, yeah, we cut it crazy, but that's our slice of pizza. What part of the crust of the pizza is coming with us? Between what and what? If this is our slice of pizza. What piece of the crust of the pizza will be moving with us? Between what and what?
Wait, you said the part of the creep.
Yeah, so if this was a piece of pizza, and you taking the piece of pizza out of the out of the pie, what part of the crust is coming with you? If this is your piece, between what and what?
Yeah, right.
If I'm taking this slice of pizza out, E gonna be there. This side is gonna be there.
Oh, so it's gonna be the other side.
I'm taking out this piece from here, down here, up here. I'm taking that whole piece out. So which part of the edge, or what would be the crust of the circle, is coming with me when I take this piece out? All of this in here is moving with me. All of this is coming with me. So where's the arc?
The only part you taking out is A, wouldn't it?
No, if I'm taking out A, don't I have to take? I gotta take out the edges too, don't I?
Wait, hold on.
So I'm pulling out A. So take all of that. Take all of that. So what else is going?
A, F.
And what?
And D, right?
Not D.
A, F. Wait, hold on. A, F. A, F, E.
Go the other way. Start with F. Remember, you saw the angle FDB.
So it's FAB then.
But do we include the A? Is that the minor arc or the major arc? Count it. How much is it? What's the measure? It starts here.
It would be a major, minor.
Because what's the measure? Start here.
40. It's 30. It's 320.
10. No, from 320 to 40. Count that.
Wait. Oh, wait. I'm going the other way. Oh, right. Yeah. So you got 10, 20, 30, 40, 50, 50 and 20. Wait, am I at 50 and 20?
No,
or
10. You count by 10.
All right, 60, 70, 80.
Okay, so this has to be the minor arc because it's only 80 degrees. All right, so now. So we got the arc from F to B, and we know it equals 80 degrees. So that means you went from F to the right to end at B. Now go the other way. Start at F, but this time, since it is a major, you got to pick somebody up along the way. Okay? So now, so the minor arc between F and B is 80 degrees. So remember, the major arc starts at the same place. You pick somebody up along the way, and then you stop at the same place. So name the major arc.
The major arc is hold on.
Remember what you did to get the minor arc. You started at F and you went to the right. So to get the major arc,
I gotta go to the left, right?
Yes, and you're gonna do what? Pick up a friend along the way.
All right, so I don't know about my screen up. And so wait, the
start at the same place as the minor arc.
F. I'm on my phone. Keep rotating F.
Pick somebody up along the way.
Is we picking up A or no?
You can.
All right, then yeah.
And where we ending? End at the same place.
At B.
And if the minor arc is 80 degrees, what's the measure of the major arc? Because the two of them, you know what they had to total.
Yeah, they got a total 180. I mean, yeah, that's right, right?
No. What's the whole circle?
Oh, no, 360. My fault, 360. Yes. I got you. The total is 280.
Okay. So now, we still haven't found the actual measure of the angle. So the relationship is an inscribed angle is half the measure of its related arc. So if this arc is 80 degrees, then the measure of this angle is 40 degrees. And it is 1/2. All righty. So an inscribed angle, and I'm going to do this a little better for you. So the inscribed angle is half the measure of the minor arc. So this is the related piece of the arc. Again, like I said, when you think about this as a pizza. And if you pull your slice of pizza from the whole pie, which part of it is going to move? Well, the part between F and B. So if this is the arc and it is 80, then the inscribed angle is half of that, so it's 40 degrees. Okay? So, so far close. We finally got to the end of this one. This is a good thing. So when we talk about arcs and angles, a minor arc is less than 80 degrees, but is actually greater than 0, but less than 180 degrees. Oh, oh goodness. Wait, I did something that I don't know what I did. Okay. Okay, sorry about that. So 0 is less than the measure of the minor arc, which is less than 180 degrees. A semicircle equals 180 degrees. It is half of the circle. And a major arc is greater than 180 degrees. And remember, the measure of the major arc plus the minor arc is going to equal 360. It's going to give you the whole circle. So you can see here, the minor arc falls between A and B. Now, they don't have another letter out here for you to name the major arc. But they have, again, labeled them both. And again, this is a central angle. Okay? So, the minor arc is less than 180. The major arc is greater than 180. When we talk about inscribed angles and central angles, the central angle is HRS because, again, it has its vertex at the center of the circle. It is 40 degrees. Therefore, the arc, if we were to pull that portion of the circle from HRS, if we pull this piece of the circle out, this arc, this edge of the circle between H and S comes with us. And those two match. However, when we look at the measure of the inscribed angle from H to M to S, it would be half the measure of the arc, because it's still related to that same arc. If we pull out the inscribed angle, HMS, we would still be pulling out this portion of the circle. We would still be pulling out that arc. So, because this is the related arc at 40 degrees, the inscribed angle, the value of X would be 20 degrees. Okay? So let me add to this. So for us, the central angle is HRS Oh. I'm just trying to line up the equal signs because that drives me nuts. Okay, so angle HRS is equal to arc HS. And then the inscribed angle is HMS. Oops, sorry. All right, so I guess I could have highlighted that a different color. But so the measure of angle HRS, which is the central angle, is equal to the measure of the arc from H to S. And then the measure of the inscribed angle HMS is equal to half the measure of arc HS. Okay? Make sense? Maybe a little bit? Something? All right, well.
Yeah, it makes sense. My fault.
All right,
My
okay.
phone got retarded.